China's plan for total economic domination is almost finished, and the infrastructure is already operational. You're about to see 15 megaprojects that rewrote global trade routes while the world wasn't paying attention. $1 trillion deployed. 150 countries connected. 15 years of construction that turned economic theory into concrete, steel, and asphalt spanning 3 continents. This is the Belt and Road Initiative, and it's not a proposal anymore. We're starting with a highway corridor that required convincing rivals to cooperate. 15. Bangladesh, China, India, Myanmar Economic Corridor. You're looking at a highway network spanning over 1,600 miles through 4 countries. The Bangladesh, China, India, Myanmar corridor required building standardized border crossings that could process freight trucks in minutes instead of days. The engineering challenge? 320 bridges and 47 tunnels just to maintain grade through the highlands. Concrete poured continuously for 18 months. Asphalt laid at rates exceeding 3 miles per day during peak construction, 6 years from groundbreaking to operational. The payoff? Freight capacity of 12,000 trucks daily moving between the Bay of Bengal and inland China. Trade routes that previously required ships circumnavigating Southeast Asia now run on roads built to handle 40-ton loads. But highway corridors are nothing compared to what happens when you electrify a railway through a desert that reaches 130 degrees. 14. Djibouti-Addis Ababa Railway. You're staring at 470 miles of electrified railway cut straight through the Afar Desert into the Ethiopian highlands. Sea level to 7,900 feet elevation in 4 years. 38 tunnels bored through solid rock. 65 major bridges spanning gorges. Desert temperatures that buckled steel rails required thermal expansion joints every quarter mile and 3 million tons of crushed granite ballast to stabilize the roadbed. Overhead catenary wires strung for 470 miles. Power substations every 30 miles, feeding 25,000 volts into the system. The payoff? Trains moving at 75 miles per hour carrying up to 3,500 tons. Transit time from port to capital, 12 hours versus 3 days by truck. But electrified railways are impressive. Until you see what happens when you combine a deep water port with pipelines that bypass an entire ocean. 13. Kayauk Piu Port, Myanmar. You're looking at 10 berths on the Bay of Bengal, capable of handling the largest container ships afloat. But the real revolution is buried oil and gas pipelines running 480 miles directly into China. Port construction required dredging 40 million cubic yards of seabed to achieve 50 feet of draft depth. The breakwater stretches nearly 2 miles, 4 million tons of rock quarried and barged into position. Twin pipelines tunnel through Myanmar's mountains. Crude oil pipeline, 28 inches in diameter. Natural gas pipeline, 36 inches. Both operating at pressures exceeding 1,000 pounds per square inch. 42 pumping stations for oil. 16 compressor stations for gas. 5 years from excavation to operational flow. The crude pipeline now moves 440,000 barrels daily. The gas pipeline? 16 billion cubic yards annually. The payoff? Oil tankers from the Middle East dock at Chokepoints, and cargo flows inland through steel pipes instead of vulnerable shipping lanes. But pipelines move resources, railways move everything else, and the next one barely touches the ground. 12. East Africa Standard Gauge Railway, Mombasa, Nairobi. You're standing at 294 miles of railway, punched through Kenya, in 5 years flat. Standard gauge track laid across terrain, transitioning from coastal lowlands to 7,200 feet of elevation. 98 bridges, 21 tunnels. But here's what makes construction insane. This railway had to coexist with wildlife migration routes. Underpasses tall enough for giraffes, 16 feet of clearance. Overpasses with natural vegetation for elephants. Prefabricated concrete sleepers delivered by the thousands. Rails welded into continuous quarter-mile sections. At peak construction, crews laid over 1 mile of track per day. Automatic train control across the entire route. GPS tracking for every locomotive. Fiber optic cables running parallel for real-time communication. Trains now run at 75 miles per hour. Travel time, 4.5 hours versus 10 by road. Freight capacity, 22 million tons annually. But this railway connects a port to a capital. The next port was built on borrowed time and became something else entirely. 11. Hambantota Port, Sri Lanka. You're looking at a deep-water port that Sri Lanka couldn't afford to finish, so it became Chinese infrastructure on a 99-year lease. Construction required blasting through coastal rock to create a harbor basin with 59 feet of depth. 18 million cubic yards of rock and sediment removed. The breakwater alone is nearly 3 miles, 5 million tons of quarried stone placed to withstand monsoon waves exceeding 20 feet. 4 berths with gantry cranes standing 230 feet tall, capable of lifting 65 tons. The terminal required 400,000 cubic yards of concrete. Bunkering facilities hold 140 million gallons of marine fuel. 4 years, from empty coastline to operational port. Cost? $1.5 billion. When payments failed, the port transferred to Chinese operation. The payoff? A deep-water port on the Indian Ocean's primary shipping route, now processing traffic that bypasses Indian ports entirely. But if one port on a shipping lane is valuable, imagine controlling a railway where 70% of the route floats in midair. 10. Laos-China Railway. You're staring at 262 miles, where only 30% actually touches the ground. The rest? Suspended on bridges or bored through mountains. 167 tunnels. The longest stretches over 12 miles, continuous underground railway carved using tunnel boring machines. Each TBM cost $30 million. Machines advanced 50 feet per day through solid rock. Crews installed concrete tunnel liners, 14-ton segments fitted like a jigsaw puzzle. 301 bridges. Some spanning valleys over 300 feet deep. The tallest piers reach 170 feet from valley floor to bridge deck. 6 years of continuous construction, over 40,000 workers. Final price tag? $5.9 billion for 262 miles. That's $22 million per mile. The payoff? Freight trains now run from Kunming to Vientiane in 10 hours. Before this railway? 3 days by truck on mountain roads that killed dozens of drivers annually. But building a railway through mountains is one challenge. Taking over Europe's gateway port is an entirely different kind of domination. 9. Piraeus Port, Greece. You're looking at the largest port in the Mediterranean, and 67% is now Chinese operated. When Chinese operators took control, Piraeus handled 1.5 million containers annually. They didn't renovate, they rebuilt 3 new container terminals on reclaimed land. Dredging to 56 feet of depth, 14 million cubic yards of fill extending the port into the sea, 15 automated rail-mounted gantry cranes, each moving 40 container lifts per hour. Automated guided vehicles run beneath the terminals on embedded tracks, moving containers without human drivers. Direct rail lines built to Central and Eastern Europe. Trains now roll from Piraeus to Budapest, Prague, and Warsaw on dedicated freight corridors. 8 years to transform an aging port into Europe's 4th largest container facility. Current capacity? 5.6 million containers annually. That's a 373% increase. The payoff? Chinese goods arriving at Piraeus reach European consumers 3 days faster than goods landing at Rotterdam or Hamburg. But a single port in Europe is nothing compared to 10,000 trains crossing an entire continent. 8. China-Europe Railway Express. You're watching 10,000 freight trains annually crossing 7 countries between Chinese factories and European distribution centers. 7,000 miles of coordinated routes operating like a transcontinental conveyor belt. The challenge? Different track gauges. Chinese and European standard gauge is 4 feet, 8.5 inches. Cross into Kazakhstan or Russia and it jumps to 5 feet. Solution? Automated bogie exchange systems at every border crossing. Hydraulic lifts raise each container car. Workers swap wheel sets in 90 minutes. Customs inspections at 7 borders could delay trains for days. Chinese operators funded unified customs facilities where inspectors from both countries work side by side. Inspection time dropped from 8 hours to 45 minutes. 43 cities in Europe now have Chinese-built rail terminals. The largest in Duisburg handles over 50 trains weekly. Loading happens in Chongqing, and 14 days later, containers arrive in Hamburg or Madrid. Compare that to 40 days by sea. Construction investment? Over $16 billion in rail upgrades, terminals, and border facilities. Built incrementally over 12 years, while trains were already running. But moving manufactured goods across continents is impressive until you see the infrastructure built to move energy at a scale that powers entire regions. 7. Central Asia-China Gas Pipeline. You're looking at 4,350 miles of steel pipe from Turkmenistan to Shanghai. 3 parallel lines, each 36 inches in diameter, moving 38 billion cubic yards of natural gas annually. Construction started in the Galkanish gas field, where summer temperatures exceed 120 degrees. 36-inch steel pipe, 40 feet per section, welded together in continuous strings. Over 100,000 individual welds X-rayed for integrity. The pipeline crosses the Karakum Desert, where sand dunes shift constantly. Engineers buried pipes 6 feet deep with concrete weights every half mile. 16 compressor stations along the route. Massive machines generating 30,000 horsepower, pushing gas at 1,450 pounds per square inch. River crossings used horizontal directional drilling, boring under riverbeds at depths exceeding 100 feet. Drill path accurate within 3 feet over half a mile. Construction timeline? 5 years for the first line, 3 for the second, 2.5 for the third. The payoff? Energy flowing continuously since 2009. 38 billion cubic yards annually, enough to heat 100 million homes. But gas pipelines feed existing cities. The next projects built entire cities from nothing. 6. Special Economic Zones Network. You're looking at 77 special economic zones built from scratch across Pakistan, Kazakhstan, Uzbekistan, Cambodia, and a dozen other countries. Power requirements first. Each zone required its own power plants. Coal-fired stations generating thousands of megawatts. Solar farms covering thousands of acres. Combined cycle gas plants. Total power generation added? Over 23,000 megawatts. Water infrastructure. Wells drilled hundreds of feet deep. Treatment plants processing millions of gallons daily. Distribution networks with pipes ranging from 6 inches to 36 inches. Water systems alone cost over $4 billion. Multi-lane highways with reinforced concrete pavement for 40-ton trucks. Rail spurs connecting zones to national networks. Pre-engineered steel factory buildings with clear spans up to 300 feet. Average zone went from empty land to operational factories in 30 months. The fastest? 18 months in Cambodia. Current manufacturing output from these zones? Over $200 billion in goods annually. Textiles, electronics, automotive parts, steel products, building materials. But manufacturing zones need connectivity, and the next infrastructure doesn't move goods, it moves data at light speed. 5. Digital Silk Road infrastructure. You're looking at fiber optic cables stretching over 75,000 miles across continents and ocean floors. Each cable bundle contains up to 288 individual fiber strands, each transmitting 100 terabits per second. Mountain crossings in the Pamirs required drilling through solid rock at altitudes exceeding 13,000 feet, where oxygen levels made labor nearly impossible. Pakistan's northern mountains required blasting 270 access points into cliff faces just to string fiber. Undersea cables run over 7,500 miles from Asia to Europe. Laying cable requires specialized ships maintaining precise GPS positioning. Fiber strands are 9 microns in diameter. Splicing requires fusion welding with precision measured in fractions of a micron. Failure rates had to stay below 0.01%. Data centers at 19 key nodes. The largest spans over 1 million square feet, containing over 100,000 servers. The Pakistan data center alone requires 150 megawatts of dedicated power. The 5G network required over 400,000 towers erected in 3 years. Construction, investment, $79 billion. Timeline, 8 years from first fiber strand to fully operational 5G coverage. The payoff? Data transmission latency between Beijing and Berlin dropped from 120 milliseconds to 48 milliseconds. But data moves instantly. The next port was built to move physical cargo that changes the balance of power in the Arabian Sea. 4. Gwadar Port, Pakistan. You're staring at a deep-water port carved into the Arabian Sea coastline, where only fishing villages existed. Built in 7 years. The port required excavating 68 million cubic yards of rock and sediment for draft depths reaching 52 feet. Dredging ran continuously for 19 months. The breakwater stretches 4.5 miles, 8 million tons of rock quarried from mountains 30 miles inland. Quay walls, 1,300 feet of reinforced concrete built using slip-form construction. Walls anchored to bedrock 70 feet below the seabed using steel pilings driven by hydraulic hammers, generating 600,000 foot-pounds of force per blow. 4 berths with superpost Panamax gantry cranes weighing 2,000 tons each. The cranes lift 75 tons and load or unload a container every 90 seconds. Oil tanker berths with pipeline connections to storage facilities holding 210 million gallons of crude oil. Pipelines 48 inches in diameter pumping crude at rates exceeding 60,000 barrels per hour. The free trade zone behind the port covers over 2,300 acres. Roads, power lines, water treatment supplying 12 million gallons daily, 6 million square feet of warehouse storage. Gwadar connects directly to the Karakoram Highway. Cargo unloaded here reaches inland China without ever crossing another coastline. Current capacity? 400,000 containers annually, with expansion plans to triple that. Oil throughput? 200,000 barrels per day. But a single port, even one this massive, is just an endpoint unless it connects to something larger that makes the entire system work. 3. China-Pakistan Economic Corridor. You're looking at nearly 2,000 miles of integrated infrastructure connecting Gwadar Port to Kashgar in western China. Highways, railways, pipelines, fiber optics, and power plants built simultaneously as one coordinated system. The centerpiece is the Karakoram Highway reconstruction. Engineers widened it from 2 lanes to 4, reinforced unstable sections, and added tunnels where the old road clung to mountainsides. The highest section crosses Kunjarab Pass at 15,600 feet. At this altitude, concrete curing times triple because reduced oxygen slows chemical reactions. 24 major tunnels bored through mountain ridges. The longest stretches 3.1 miles through solid granite, over 700 bridges spanning gorges, rivers, and valleys. The Adabad Lake Bridge stretches over 3,000 feet across a lake that didn't exist when construction planning started. Twin pipelines buried alongside carry oil and natural gas from Gwadar to Punjab province. Oil pipeline, 30 inches in diameter. Gas pipeline, 42 inches. Both operating at pressures exceeding 1,400 pounds per square inch. Fiber optic cables trenched alongside the entire route, 48-strand bundles providing connectivity to cities that previously relied on satellite links. Power infrastructure added over 14,000 megawatts. Coal-fired plants, wind farms, solar installations, hydroelectric dams, transmission lines required over 16,000 high-voltage towers, 9 special economic zones built along the corridor. Complete cities designed for manufacturing. The Rashikai zone alone covers 2,000 acres with infrastructure to support 500 factories. 8 years from initial groundbreaking to operational status. Over 75,000 workers on simultaneous job sites. The investment? $62 billion. But CPEC is one corridor. The real transformation happens when you connect dozens of ports into a single network that spans 3 oceans. 2. String of Pearls Port Network. You're looking at 15 major ports, constructed or expanded simultaneously, from the South China Sea to the Mediterranean, an integrated maritime highway controlling 80% of global trade by volume. Combined berth construction required dredging over 400 million cubic yards of seabed. Each port needed draft depths between 50 and 60 feet. Breakwater construction consumed over 60 million tons of quarried rock. Quay walls used over 12 million cubic yards of concrete. 173 superpost Panamax cranes installed across the network. Each crane costs $14 million. The cranes at Piraeus reach across ships 25 containers wide over 160 feet of span, lifting 75-ton loads every 90 seconds. Automated guided vehicles run on embedded track systems. The Khalifa port deployed over 50 automated vehicles coordinating via 5G networks, maintaining throughput rates of 40 container moves per hour per vehicle. Bunkering infrastructure holds over 2 billion gallons of marine fuel. Transfer systems use 48-inch pipelines, pumping 12,000 gallons per minute, refueling an ultra-large container ship in under 8 hours. Rail connections at 13 ports. Over 400 miles of new track. The Piraeus rail connection handles 30 trains daily, moving to Central Europe. Fiber optic networks connect every port in real time. Ships transmit cargo manifests digitally before docking. Container tracking uses RFID systems logging every movement. Average construction time? 6 years from initial dredging to operational capacity. Total investment? $147 billion across 15 ports in 12 countries. Current combined throughput? Over 130 million containers annually. Add bulk cargo and the network handles over 2 billion tons yearly. Oil and gas facilities process over 4 million barrels daily. Yet even this massive port network is just the supporting infrastructure for what comes next, the project that makes everything else possible. 1. New Eurasian Land Bridge. You're looking at the largest coordinated infrastructure project in human history. A transcontinental system spanning over 8,000 miles from the Pacific coast of China to the Atlantic ports of Europe. This isn't one project, it's hundreds integrated into a single functioning system that moves cargo across an entire continent in 2 weeks. The railway network required standardizing track across 65 countries. Over 37,000 miles of rail upgraded. Bridges rebuilt. Tunnels expanded for double-stacked containers. Automated switching systems installed at over 300 major junctions. Gauge change facilities at border crossings. Process trains with surgical precision. The Dostik facility processes 20 trains daily. Hydraulic lifts raise 50 freight cars simultaneously. Crews have 12 minutes per car to swap wheel sets. Highway network construction? Over 22,000 miles of roads upgraded to handle 40-ton trucks. Reinforced concrete roadways 18 inches thick in high-traffic sections. The Corgos Gateway is the largest dry port in the world. 600 acres of switching yards, gantry cranes, inspection facilities. The facility processes 9,000 containers daily. Pipeline network running parallel to rail and highway corridors. Over 12,000 miles of infrastructure with diameters ranging from 12 inches to 48 inches. Oil pipelines from Russia and Kazakhstan. Gas pipelines from Central Asia. Water pipelines supplying arid regions. Fiber optic cables trenched alongside every major route. Over 50,000 miles of cable containing up to 432 individual fiber strands per bundle. Power infrastructure? Over 190 power plants built or upgraded. Combined generating capacity exceeds 97,000 megawatts. Over 85,000 high-voltage towers and 43,000 miles of cable, carrying up to 750,000 volts. Container terminals built at 72 strategic cities. The Chengdu terminal covers 4,000 acres and processes over 3 million containers annually. Warehousing infrastructure totals over 400 million square feet. Climate-controlled facilities with automated inventory management, RFID tracking, loading systems that fill a truck in 12 minutes. The largest warehouse complex in Duisburg spans 6 million square feet. Digital integration ties it all together. Every train, every truck, every container tracked in real time through GPS and RFID systems. Customs documentation transmitted electronically before cargo reaches borders. Inspections through X-ray scanning without unpacking containers. Construction timeline? 15 years. First sections operational in 2008. Full continental connectivity in 2023. That's standardizing infrastructure across 65 countries, while trains were already running on partially completed sections. Total investment? Between $800 billion and $1 trillion. Railways, highways, pipelines, fiber networks, power plants, terminals, warehouses, border facilities, digital systems spanning 8,000 miles. Current operational capacity? Freight trains moving over 15,000 containers daily, from Chinese factories to European distribution centers. Transit time from Chongqing to Duisburg? 14 days. That's less than half the time required for ocean shipping. Trucks running highway corridors move an additional 8,000 loads daily. Pipeline systems transport 93 billion cubic yards of natural gas and over 2 million barrels of oil every single day. This is what total economic domination looks like when it's finished. Not a proposal, not a plan. Operational infrastructure moving trillions of dollars in trade across a continent. Railways that can't be blockaded. Highways that bypass maritime vulnerabilities. Pipelines that flow regardless of naval power. The Belt and Road Initiative isn't coming. It's here. It's operational. And it's already moving the cargo that used to depend on routes China didn't control. 15 years of construction at a scale no one thought possible. 150 countries connected through infrastructure that rewrote global trade. And while debates continued about whether this could work, China poured the concrete, laid the rails, and built the system that now carries 70% of Eurasia's freight.